Hi friends, this is K. Murali. Today we are going to discussion about adiabatic process. Adiabatic process, PROCES process, adiabatic process. What is the adiabatic process? In this adiabatic process, during the adiabatic process, no heat transfer take place, but work done due to expansion of internal energy. As there is no heat transfer, entropy remain always constant. Therefore, adiabatic process is more same times referred as asymptotic process and represented by a vertical line in HS and HS and TS diagrams. So we are draw here. Look at these diagrams. This is the pressure and this is the volume. So here observe here starting point is like this. First B, this is the A and this is the B, and increasing line like this. So this is the point 2, this is the point 1 here. So this is the dotted line, this is the D, this is the C. So example like this. So this is pressure and volume diagram, and this is the temperature and entropy here. Observing this line same as. So here this is the pressure 2, this is the pressure 2 and this is the pressure 1, C constant. So this point is A dotted line, this is the B, and this is the 2, this is the 1, and here to here Q, this line is touching here Q. So this is the D, this is the C, and this is the D. So this is the temperature and the entropy, and third figure is showing here enthalpy and entropy. So observe here clearly what happening here. This is the A, this is the A2, and this is the B, and this is the 1, this is the 1 2 powers, and here third one is the D and C. So this is the P1 and this is the P2 here C. These are the three steps on 2 D C. So this is the TS diagram, this is the TS diagram, this is the HS diagram. So this is the HS and this is the TS. So let 1 kg of steam expand from initial pressure and dryness fraction X to final pressure P2, initial pressure and dryness fraction to final pressure. Here for asymptotic process, asymptotic process, PROCES process, asymptotic process, entropy before expansion equal to entropy after expansion. So entropy is F1 is equal to X1 HFG1 by TG1 is equal to SF2 plus, here also plus X2 HFG2 by TG2 for asymptotic process. Here if the same initial superheated if the same initial if the steam sorry if the steam is initially superheated then soup 1 is equal SF2 plus X2 HFG2 by TZ. From the above equation, X2 can be calculated also. U1 is equal HF P1 V1 H1, and also U2 is equal H2 minus P2 V2. So here H2 minus U2. From the above equation, so from the equation Q is equal W plus U2 minus U1. So for adiabatic process, process PRCS, Q is equal to 0. So 0 equal to plus U2 minus U1. So W equal to U1 minus U2. W equal to U2 minus U2. So this is work done process here, and hence the work done during the adiabatic process is equal to the change in internal energy. So the adiabatic process can be expressed as PV power N is equal to constant such that index N will be satisfy the condition. So the index N will be satisfy the condition Q is equal to 0. So the equation between two stages, the equation between two stages or status can be written P1 V1 power n is equal to P2 V2 power n. So here work done W is equal to P1 V1 minus P2 V2 by n minus 1. This is the work. P1 V1 is equal P1 V1 minus P2 V2. So approximately the value of n for the adiabatic process or compression of the streams are n is equal to 1.13 for wet steam, n is equal to 1.3 for superheated steam. For in this process, the equation N Dr. Zeuner has suggested suggested for n. So n is equal to 1.035 plus 0.1x, where x is equal drainage fraction of the steam, x is equal to 1, therefore n is equal to 1.135 for drainage steam, 35 for dry steam or drainage steam, dry steam, that's it, dry steam. So this is about the adiabatic process. So thank you for watching this video. We will discuss next topic in next video. Thank you.